Hi, happy Friday. So today we will continue to finish the session 13.3. So chapter 13, I told you that our final exam, we only have like two problems about chapter 13. They are going to be, so if you click on the practice final exam, you can see the last problem, the number 12, is we're going to have part A as about the derivative of the trig functions. And part B is talk about the antiderivative of the trig functions. Okay? So, which means what I'm going to talk about today won't be on your final, but you will see those problems in your last homework assignment. Okay, so yeah, for the trick part, I only ask you like a differentiation and the integration for the exams. Okay, so the remaining here, like this is solving differential equation involving the trig functions. This is about find the average values, and this is about find the area and find the volume. So all the applications we learned before, we didn't involve trig functions. So we kind of just go back to those concepts and do some examples involving the trig functions. Okay, but however, and because we just learned these today, they won't be on your final exam, but they will be on your homework. Okay, but your homework, you dropped the two lowest scores. So okay, which means so today we will finish this session, and then over the weekend you can work on the practice final exam. So today I also have study session this afternoon from 3:10 to 5 p.m. in this room. Mhm. So feel free to join us for the study session. And when you study for the exam, I strongly recommend you to look at our concept map. So the concept map remind us what method we learn in each chapter, right? Everybody? Uh-huh. So yes, study the concept map, review, and then use this method to work on your practice final exam. And over the weekend, if you have questions, email me, and then we can schedule a time. We both can go to the big blue button, the canvas. Then you can share your screen. You can ask me the question, and then maybe I can help you to figure out the mistake or guide you or explain to you. Okay. So over the weekend, if you have questions, email me. And when is our exam? Yeah, Monday. Monday. hmm Okay, so this weekend, study hard and ask me questions. Do you have other exams on Monday? No. Okay. Huh? Oh, I'm the only one you have exam on final. Oh, okay. That's good. Okay, so then this weekend belongs to math. Good. Okay, so now let's continue. Okay, so how do we solve differential equation? All right. So remember differential equations. So when we like go over this problem, it could be like a review because the general method for solving differential equation, we just learned two types of differential equation. They are the separable or the first order linear. The first step is make sure you get the standard form. So look at this guy. Is this separable or first order linear? You look at the y. Is it linear? Do you see it's y to the power 1? Not quite, because it's inside the cosine. Once it's inside the cosine, it's not a linear function, right? Exponential function, trig function, they're not linear function. So this is not a linear ODE. It's a separable differential equation. Okay, so it's separable differential equation. which means we want to move all the x to the right and move all the y to the left. Do you see this guy? This is x. So we move to the right. Move, we mean multiply or divide. Okay, so both sides. Do you see here? This is the cosine. And it's the cosine square of 3y. It has the y. We should move to the left. The move, we mean divide. Because on the right-hand side is multiplication. So we want to divide it by cosine square, 3x. Sorry, 3y. And then the right-hand side, we have 7x e to the 5x minus x. And we both sides divided by x. And multiply by dx. Is that okay, everybody? It's a separable differential equation. So move the y to the left, move the x to the right. Then we can integrate both sides respectively. And before you integrate, you must make sure they're in a good form. Okay, so remember this formula sheet? Yeah, everybody practice filling out the formula sheet. And your integral must look exactly like this. Okay? If it's not exactly like this, you have to do some work to make it exactly like this. Do you have any formula about 1 over cosine squared? Do you have any formula about 1 over cosine squared? No, you don't have that. You only have integral of cosine. Right, everybody? So when you do this kind of integral, you cannot be creative. Okay? They must look like integral of cosine. Then you can use the formula. You cannot say, oh, the integral of this is 1 over the integral of cosine and then I square it. No such story. Okay? So the integral must exactly look like these ones. But what is 1 over cosine? Use the trig identity. What's 1 over cosine? 1 over secant. 1 over. Okay, so this is the concept map, right, everybody? And this is the hexagon. Do you see sine times cosecant is 1? Yeah. Cosine times secant is 1. Therefore, 1 over cosine is secant. Yes. So make sure that's why I gave you the top one. Okay. So use the hexagon to fill out the trig identities. Okay, and here. Thank you. Okay, so let's see here. 1 over cosine is secant. Therefore, this is secant square 3y dy. Yes, everybody? And then the right-hand side. We have a quotient. But do we have quotient rule? No, right? No quotient rule. So if you see a quotient, you need to split. Okay? So it's the first term over x. And then minus the second term over x. So simplify. First, right, everybody? Here, make sure you simplify. If you have some x power, we want to combine the x power. Or if you see some exponential function, you also want to combine the exponential functions. Everybody? And therefore here, look at the first term. You see x and x. Okay. Thank you. That actually makes the problem easier because now you just integrate e to the 5x. If you have an x power here multiplied by e to the 5x, you actually need to do integration by parts. Right, everybody? So here, after we do the calculation, the problem actually becomes simpler. Okay, now look at the left-hand side. Look at your formula. Do you have integral of secant square? Have integral of secant square? Yes. What is integral of secant square? Mm-hmm. What's integral of secant square? Yeah, 1 over a. What is a? 3. Tangent 3y. Yeah, everybody? And the plus c, we don't need to do plus c on the left because we just do plus c on the right. We don't want them to cancel out. Okay, on the right hand side. X cancel. What's integral of 7e to the 5x? Multiply by 5 or divided by 5? And then e to the 5x. Right? Integral divided by 5. How about, see the 6 constant multiple stays here. What is the integral of 1 over x? ln x. Yes. ln x plus c. Okay, everybody? All right. Now, what do? We want to find the c. Yes. So we plug in the initial condition. We plug in x is what? Yeah, x is 1 and y is 0. Okay, so on the left, we get a tangent y is 0. So 3 times 0, still 0. But x is 1. Okay, e to the 5 times 1 is 5. 6 ln 1. Do you remember what is ln 1? Yes, 0. Plus c. Okay. Do you know what is tangent 0? At tangent 0. So what's the tangent graph look like? The x cubed, right? This is pi over 2. That's 0. That's negative pi over 2. So tangent of 0 is 0. Oh, you said that? Yeah. Here's the sorry. So this is 0. Yes, sorry. Okay, then we find the c. So c is, we move this to the left, it becomes negative. Everybody? Wonderful. After we get the c, we just rewrite everything. So final answer, 1/3 tangent 3y is 7/5 e to the 5x minus 6 ln absolute value of x. C is negative 7/5 e to the 5th. So this is the final answer. Okay, everybody? Yes. So this is a separable differential equation. You can also have one first order linear. Okay, but maybe your usually the p is either a constant or a constant over x. Then some sound. Okay, so let's put it here. So for first order differential equation, I don't put an example here, but I want to remind you what it looked like. So you have p times y equals q. This is the first order differential equation. Remember your exam? The first step, you have to make it to the standard form. Many examples we learned the p is either a constant. if P is a constant, okay, if P is a constant, let's say P is minus 5, then your integrating factor is e to the integral P dx. So e to the integral 5x. So your integrating factor is exponential. And then you have what? Y times the integrating factor equals the integrating factor times q dx. Remember? And on your right hand side, you need to distribute to cancel. If you have exponential function, you need to combine them, right? Everybody? Mm-hmm. This is what happens when your p is constant. And other possibility is when p is like a constant over x. Let's say this is minus 5 over x. Then your mu, let me use a different color. Your mu will be integral, so e to the integral negative 5 over x dx. Do you see this is e to the minus 5 ln absolute value of x? And the minus 5, you can bring this to the exponent. This becomes x to the negative 5. Your integrating factor is the power function. And then you do the same thing here. Y times the integrating factor is integral, the integrating factor, the power function, times your q. So now your q could be exponential function, a power function, or trig function. Okay? But hopefully, after you multiply by this integrating factor, you only get integral of the trig function of this form. You should not have like in the cosine times the x power. The x power should be equal. Okay, everybody? So this is the idea of this. Okay. So that's why make sure you simplify. Okay? Combine the x power or combine the exponential functions. Yes. Okay. And example 4. Find the average value of this function on the interval from 0 to pi over 2. Okay. So, do you still remember our average value? We compute the integral from a to b, and then we divide it by the length of the interval. Right? Then we can find the average height. Let's say this is like the average height. Okay? And so let's see here. The average value for 0 to pi over 2. This is, so usually we put a bar on top f to denote the average. That is 1 over b. This is the b. That's the a. So pi over 2 minus 0. Plus u. Integral from a is 0 to pi over 2 of our function. But now we allow our function to have trig functions. Okay, so we have trig functions, dx. Average value is something we learned before, but now the function has trig function in it. All right. So let's see, how do we solve this? Does this look exactly like the formula? No. Okay, so we need to do something else, right? And the something else, two methods. Either use substitution or integration by parts. I told you integration by part is always some power function. X to the a times either exponential function or log or sine. Okay? But here, do you see any power function? No. So for sure, no integration by parts. Then it must be u substitution. U substitution, you should see a composite function. Do you see a composite function? Sine x to the fourth. And u is the inner function, right? U is, so u substitution. Okay, and no integration by parts. Because it does not look like a x to the a times e to the bx, or x to the a ln bx, or x to the a cosine bx, or x to the a sine bx. Okay, the integration by part we learned must be in this form. Therefore, it must be u substitution. So you see a composite function, composition, and we let u, so this is a composite function. This is like sine x to the 4. Therefore, the inner function is the u. Right, everybody? Okay, so u is sine x. What is du? What's the derivative of sine x? Cosine x. Yes. Okay. And now, let's see. Oh, cosine x dx. We have differential. So both sides, we must see the d. And we continue. That is 1 over pi over 2. Integral from, okay, these are the x. Okay, so x is from 0 to pi over 2. So u of 0, u of pi over 2. 12. Do you see cosine x dx? They become the du. So put the du at the end. And then sine is u. This is u to the 4th. Okay. By the way, what's 1 over pi over 2? Yeah, 2 over pi. So this is 2 over pi. Can we move the 12 in front? Yes. So multiply by 12. And now we can integrate u to the 4. What's integral u to the 4? Yeah, very good. Evaluate from u of 0. You can, so you can change the x values to u values, then plug in your u. Or you can get your x back and then plug your x value in your x. So up to you. But here, let's see, we can plug the 0 into sine. What is sine 0? What's sine 0? Yeah, what's sine pi over 2? 1. Yee, nice. Right, everybody? Okay, they are u values. We are ready to plug in. Let's move our numbers together. 2 times 12. Yes, so 24 upstairs and 5 pi downstairs, right? And then we plug in u plug in u is 1. So 1 to the 5th minus what plug in 0, 0 to the 5th. Right? 1 to the 5th is 1, 0 to the 5th is 0. So we just get 24 over 5 pi. So this is the answer. Average value. Very nice. It's a review of average value. And just now, your function might involve trig function. Okay, good. Let's keep going. Now, area bounded by the graphs. Okay. Applications, we have area and volume. Okay, so area. Let's kind of sketch the picture. Okay, so we have 3 sine x. Okay, we know sine x looks like this. When you multiply by 3, your amplitude is now become 3. everybody? E to the 2x. What's exponential function look like? Exponential function look like that, right? Like that. So they kind of look like that. And now we're talking about, I think there is typo. I mean x is 0 and x is pi over 2. Okay, so x is 0 is here, x is pi over 2 is here. Then we're asking to find the area of this region. Okay, so yeah. Now let's see. What is the area? Area is sum of the area of rectangles. Okay? And the sum of the area of the rectangles, you kind of cut this into many rectangles, right? Each rectangle, you talk about the width and the height. The height is you using the upper function minus the lower function. Yes, everybody? That's why the formula is integral from a to b. Upper function minus the lower function, dx. So use understanding. Draw the picture. Then you can use it. So not just memorize, but understanding it. What is the area rectangle? Length times width. Width is dx. Length is the difference between the two functions. Okay, we have two functions. Who is the upper function? The sine or the exponential function? Exponential function. And our x is from 0 to pi over 2. Right, everybody? Upper function, the 2e to the 2x plus 5 minus the lower function, 3 sine x dx. Everybody? Okay. We set up the integral. And they are already simplified, right? We look at each term. 2 e to the 2x. Look at your formula. What's the integral of that? Exponential function. Yes. So the 2 constant multiple times the integral of e to the 2x is e to the 2x over 2. How about the 5? What's integral of 5? 5x, yes. And what's integral of sine x? What's integral of sine x? Look at your formula. Yes, negative. But because in here, a is just 1, right? So we only get negative cosine x. And then we evaluate from 0 to pi over 2. Everybody? So make sure each term must look exactly like. So if it's something different, which means we need to do more. Maybe if there's a product, you have to distribute. Maybe there's a fraction, you have to split the terms and do some cancellation of the x powers. Okay, now let's see. This means we plug in x's pi over 2 first, plus u, minus 5 x is pi over 2. Do you see this become plus? plus 3 times cosine pi over 2. And then minus, we plug in 0. The first term, do you see it become e to the 0? The second term, 5 times 0. And then 3 cosine 0. Oops. Okay. Let's try to simplify. We have 2 cancel. We have e to the pi, right? And then 5 pi over 2. What is cosine pi over 2? Yes, so this is 0. And then what's e to the 0? 1. And what's cosine 0? Yes, also 1. Ooh, look at this. 1 plus 3 is, oh, yes, everybody? So this is minus 4. Okay. So just leave it like that. Okay. All right. So this is about area of a region. So when you read a problem in the exam, read it slowly. Okay, is it area or is it volume? Okay. So, oh, by the way, everybody finished this problem? Okay, so last problem. Find the volume of the solids generated by rotating the region R about the x-axis. R is the region bounded by 5 cosine 2x. Okay, so 5 cosine 2x, it looks like a cosine, so it looks like something like this. And, let me draw it better. Maybe like that. And then y equals 0. Okay? X equals to 0. Okay? There's a typo. And x equals pi over 4. Do you see when you plug in x is 0? Cosine 0 is 1. You get 5 times 1, 5, right? So as 0, this is 5. And when we plug in x is pi over 4, what happened? Pi over 4 times 2 is pi over 2. Right, everybody? Pi over 4 times 2 is pi over 2. What's cosine pi over 2? Cosine pi over 2 is 0. Yes. So at pi over 4 is actually 0. So this is our region R. Everybody? And now we want to rotate this region about the x-axis. Okay. So how do we do that? Remember, we draw a little rectangle vertically. Then this is the x.
Sorry to interrupt you. Can I just put?
Yeah, sure. No
Sorry,
problem.
I don't want to be.
Oh, no problem. Yes. Okay, so then we have the endpoints of the rectangle. We want to imagine what happens to the endpoint when we rotate about the x-axis. Look at this endpoint when you rotate. What happens? It stays here, right? Everybody? How about this endpoint when you rotate? You get a circle, right? Do you remember Washer method, this method? If you have 1 R, then it's only this method. If you have 2 R, then your volume, okay, is sum pi big R squared minus small r squared dx. Right? In this case, we only have one r, so we don't have r squared here. We only have a disk, not a washer. Okay, but then do you see the big R is our function? Our function is 5 cosine 2x. Anybody? Okay, so then we have integral from x is from 0 to pi over 4. Pi, we can move the pi in front of the integral. And then we have the function. The function is 5 cosine 2x squared dx. So when you compute the area, you just have the function. But when you compute the volume, you have the square. Because of the pi r squared here. The cross-section area, pi r squared. All right, let's try to simplify this. 0 to pi over 4. What is 5 squared? 25. And then this is cosine 2x squared dx. Everybody? Mm-hmm. A 25 we can move in front because it's a number. But then how do we integrate cosine squared to x? Okay, a formula. Do you have a formula for cosine squared? No. You have a formula for cosine x, but not squared. Okay? And we cannot be creative. We cannot say, oh, it's the integral cosine and then we square it. That's wrong. This is not true. So we cannot do that. So here we need a trick. The trick is called double angle formula. Okay. So we have formula for the cosine 2x, but we do not have formula for the cosine squared. No direct formula. Therefore, you need to use double angle formula. Okay. What's double angle formula? Sine 2 theta is 2 sine theta cosine theta. Yes, remember you applied a trick a long time ago? You learned the double angle formula. And we also have cosine 2 theta is 2 cosine theta squared minus 1. And is also equals to 1 minus 2 sine theta squared. Everybody? Okay, so this guy, we have the square. The problem we get stuck is because of the square. If we can get rid of the square, we're able to integrate that. Okay? So we want to get rid of the square. Let's use this equation. Use this equation. And let's solve for cosine square. Do you see cosine square? We add 1 on both sides, and then we can divide it by 2. How do you solve for cosine square? Add 1 on both sides, and then divide it by 2. Everybody? That's why we have the formula we want to use. Cosine square is 1/2 plus 1/2 cosine 2 theta. This is the formula we want to use. We want to reduce the power, to double the angle. Can you integrate a constant term? Yes. Can you integrate a cosine 2 theta? Yes. So this is the trick. No matter you see sine square or cosine square, use the double angle formula to reduce the power but double the angle. Okay, everybody? So therefore, what's the cosine squared 2x? Do you see if theta equals 2x? When you double the angle, that's how many x? Yeah, that would be 4x. Exactly. So put this back here. Oh, yes, I do. And I forgot about that. Thank you for reminding me. Yes, I missed the pi here. All right. Do you see we have a 1/2 as a common factor? Let's also move the 1/2 in front. Because I don't like to work with fractions. Let's move the 1/2 in front. Then we have 1 plus cosine 4x dx. Yes, bless you. Now we are ready. Yeah. So this is a harder problem. We increase difficulties. Yes. Okay. What's integral of 1? Bless you. X. And what's the integral of cosine 4x? Minus 1 over 4 sine 4x. And we evaluate from 0 to pi over 4. Everybody? Mm-hmm. Okay, finally, plug in the numbers. Plug in x's pi over 4. And do you see 4 times pi over 4? We just get pi. Yes, everybody? And minus, we plug in 0. So we have 0 minus 1 over 4 sine 0. And you know the sine function. What is sine pi? What's sine pi? 0. Yes. You see sine pi is 0. Sine 0 is also 0. So all this gone. Okay. So therefore we have what? 25 and pi times pi is pi squared over 2 times 4 is 8. So the volume of this solid is 25 pi squared over 8. Everybody? Okay. And this is how to find the volume. And we can kind of generalize. What are the possible type of problems we can ask? Think about that. Instead of cosine, maybe I can put a sign there. And when you have sine square, you then look at this too, and you can solve a sine square. Reduce the power and double the angle. Okay? How about some other functions? Maybe secant. If I give you secant, when you square it, oh, nice. When you square it, you get secant squared. Do you have the formula for secant squared? Do you have the formula for secant squared? Yes. See, if the function is secant, secant squared is nice. We have the formula for it. But if you have like some other like tangent, if you have tangent, when you square it, you get tangent squared. Do you have the formula for tangent squared? Look at this. Do you have formula for tangent squared? Oh, not quite. It's secant squared, but we don't have formula for tangent squared. When you have tangent squared, what you do is use the trig identity. Tangent square is secant square minus 1. Yeah, then you can use the secant square to get it. How about cotangent? Cotangent is cosecant square minus 1. You have the formula for
So
cosecant
the only
square.
two that are like running like are sine and cosine.
Yes. Right. Yes. All right. So we generalize this type of problems. But in the exam, you have volume problems, but not involving trig functions. Okay. This is just open your mind. Then you can do your homework. Okay. Any questions? So we have learned everything in applied calculus 2. So use the concept map to review all the method we learned and practice exams. And if you have questions, email me. Okay, we can go to the big blue button. You can share your screen, and then we can talk. Mhm. Okay, have a nice day. I'm so happy to be your instructor this semester. You received a class photo, right?
Yeah.
Okay, good. Bye.